Today is the second session of solved exercise. Can you hear me or not? Yes? And like this, can you still hear me? Yes? Okay. Today is second session of exercises. Before that, I would like to make two things. First, a couple of announcements. And secondly, I would like to quickly go back to the last exercises of last week, so that we can comment the solution that you already have in the portal, and then we will start the new session of exercises. Today will be devoted only to fairness computations. Regarding the first part, announcement. So first of all, I would like to remind you that I think that until tomorrow you still have the time to vote your representatives, student representatives. So I encourage you to be informed and to vote if you would like to have a meaningful representation. Then I already sent you a message on the portal with a warm invitation to follow either physically or remotely, or to look at the recorded video of this seminar that will be in Italian. The presenter, the speaker can speak also English, can answer to English. In any case, I think that the topic of this seminar is very close to most of the topics that we have covered during the course. So this is not part of the exam, the seminar. It's just encouragement that I make to you. If you'd like to deepen with a scholar who is she's a philosopher from University of Pisa. She's very in also the technical details of artificial intelligence, and her thesis is quite radical because she will show that well, according to evidence that she collected, she will show that some or even many of the current applications of artificial intelligence are violating human rights. So it will be half an hour presentation, half an hour discussion. So just a warm welcome if you would like to deepen the topics that are touched in this course. More in general, from aspects of data ethics that we will not cover during the course, but are still very relevant. In June, there will be a seminar, this time in English, that will be given by Milagros Miceli. Miceli she's a well-known scholar. She's working both at the Weizenbaum Institute in Berlin and at the Dyer Institute. This is a new institute that was created by Timothy Gebru after being fired by Google. Do you know who is Timothy Gebru? Nobody knows her? So Timothy Gebru, let me make this parenthesis because it's important. She was part of the ethics AI team in Google. And about 4 years ago, she wrote a paper that was quite important for the time. The title was On the Dangers of Stochastic Parrots. She was warning already at the time on the dangers of applications based on large language models. Of course, she was already working on the BERT model of Google. There was not yet ChatGPT was not yet there, and she was fired after this study. She and other colleagues. She became quite famous all over the world, and after that, she founded the Dyer Institute, which is a distributed. Let me show you. It's a research institute on artificial intelligence. which has the goal to improve diversity in the AI landscape. Interdisciplinary, globally distributed AI research institute, rooted in the belief that AI is not inevitable, it's are preventable, and when its production and deployment include diverse perspectives, and I will show you what is diverse perspectives, and deliberate processes, it can be beneficial. And let me show you people involved. So she puts together many important scholars from all over the world with wide representation, so now the pictures are not showing, of ethnic groups, of non-binary gender, like Alex Hanna, many people from Africa, from the global south. So trying to propose an alternative development of artificial intelligence that is not Silicon Valley based. This is the main purpose of the DARE Institute, one of the main purposes. Milagros Micheli works also in the DARE Institute. She's one of the most important scholars in the field of understanding, documenting the human labor behind artificial intelligence. And she documented in a careful, well-detailed way the work of labelers. So the people who take huge data sets and label them in order to allow the big companies to have the so-called golden truth. So labeled data sets in which they can train their model. And she documented the way labelers work, especially in South America, how they are paid, the condition of working, what their work is about. So it's a very important part of the data ethics issues that we are not, again, we are not covering this exam, but I think it will be very interesting and formative for you. It's up to you if you want to deepen this knowledge. It will be on Wednesday, 14th of July at 5 p.m. This is part of the next Wednesdays that are organized with 1 hour discussion and 1 hour presentation, 1 hour discussion. It will follow a news on the portal as usual. Okay, this concludes the part on the announcements, and let me go back now on the previous, on the solutions of the exercise that were left from last Tuesday. I will give just an overview because and answer to questions because solutions were already published since 1 week. So this is car insurance, and this is Facebook advertising. Let me check the recording. Yes. Okay, let me start from the last one, Facebook advertising platform. This was a special exam, special because it was in the special session, the one in which you can enroll only if certain conditions are met, if you are left, I think, with very few exams and other conditions that are of administrative nature. So, and it was special also because probably it was very too much simple. It was very easy. So this is below the average of difficulty. Nevertheless, I still had half of the people who couldn't pass it, and I don't know why. So this was inspired to the real case of the Facebook advertising platform. I assume that you already read the text, so I'm not reading again the text. I'm just guiding you through the solution. This is already published, and the core of the solution was to identify proxy attributes. So Facebook could not use anymore directly ethnic groups, and this is also as it is reported in the exam text. So I could not use directly African American to target people and to let African American people receive special advertisement, or Asian people receiving dedicated advertisement. This is illegal from certain domains. So it introduced other categories, and are the following ones. However, discrimination issues were still there. Why? So the question was why the discrimination issues remained also after the removal of the racial categories, and for which ethnic group? This was the question, the first question. And what was expected that you could do was to analyze this list of categories and identify for which ethnic groups they are proxy. For example, Boca Junior soccer team is clearly a proxy for Hispanic or for Latino, let's say. So this is a proxy, we can use the yellow. OSMAC country music is a proxy for the whites, for the white Caucasian ethnic group. Naim Vuzi is a proxy for the East culture, usually. Noticiero Univision, it was a proxy again for Latinos. Black Girls Rock, I think is quite self-explaining, that is a proxy for African American. Harvard is a reasonable proxy for white Caucasian. Was green. Telemundo is a proxy for Latinos. Black Lives Matter is a proxy for African American. Thai cuisine is a proxy for the East, so blue. Maldives holidays, usually they are a destination for if you have quite a lot of money, and for the global north people that goes to Maldives, I don't know the pronunciation, so we can tag it green. Latin music, well, it is from Latinos. Gospel music and hip-hop music is something that is related to African Americans. And Bollywood movies is something that is related to Indians, so to the East. Was my goal was quite easy to identify these proxies. You didn't have at this exam to come up exactly with the same organization, but you should have at least identified the most important ties. And this is you will check in the solution, or you already checked that this is actually everything is true. I've taken some of these categories from the real categories used in Facebook, and some others are invented to make them more explicit. And as a socio-technical intervention, my suggestion were, well, first of all, most obvious, to remove the proxy attributes, but this is very, very obvious. And whenever a correlation between a race and new categories arise, so a kind of monitoring algorithm that could check every time a correlation increase between a certain category used and an ethnic group is, let's say, above assuming 70% for at least 2-3 weeks, be something like this, then you should remove that category. So saying just removing the proxies is not enough. You should propose something that is original. So this is a very general example. Then you could have a calibration of the recommendation. This is what you find in the second part of the question. You could do not let the recommender go alone with its own recommendation and put caps to thresholds, to recommendations. So after reaching a certain level of targeted people, here you find example with African American. After you reach, let's say, 50% African American that are targeted with some advertisements, you stop recommending them a certain advertisement to them, and you increase the recommendations to the other groups. This is another example of possible improvement to mitigate the problem. Do you have questions? Okay, assume there are no questions. Then we have the car insurance problem. I remind you, here was an exam in which you already have discrimination, and you should explain it. With several categories, let's comment the graph that you already checked. So we have the target is repaid accident cost. This is not explicitly listed here. However, as it is written, it is a very implicit, a very direct assumption to say that, as I wrote, repaid accident costs are assumed to be the target variable for which the company has the historical data and has trained the algorithm. Because you don't have, I didn't list a target variable, but I told you that the company is using historical data, is collecting also some specific characteristics for the goal of predict higher risk of accident costs. So with this assumption, fundamental basic assumption that is retrieved from the text, you could reason in this way. So first of all, we know that, let's take car. A type of car, it has two levels, large, powerful cars that are on average, more expensive than small cars. It means that repairing them, if you have an accident, costs more. Maintaining them costs more. It means so they're directly related to higher cost, but also to wealth, because if you take a large, powerful car, usually it costs more than a small car. Then you can also reason in terms of the used cars, but still the comparison between the relative comparison between large, powerful cars and the small cars still is kept also for the used market. So if we assume the correlation with wealth, and wealth correlates with ethnic group, we have one possible explanation of the discrimination that is observed, and is related to car. The other explanation is birthplace, that is clearly related for the way the attribute birthplace is related to ethnic group, the relationship with accident cost is weaker. I exposed you in the solution a reasoning in which if you were born in another country with different rules, you might have a different driving style, you might have different habits, at least for a certain period, you might be more exposed to accidents because you are driving in a different context. I assume this as a weak correlation, not as strong as the correlation with car. Okay, so that's why I put it with a dotted line. Something else that is correlated to accident cost is the city, because if you have historical data, so assuming that historical data is trained and the company has the history of accident cost, we know that there are large differences between cities in Italy. So you pay premiums, different levels of premiums for the same car, different in Naples and Milan, in Potenza, in Trento. This is general knowledge. And well, this is also general statistical knowledge. And it was acceptable to also have this correlation, although the correlation with ethnic group is weaker. Because you have to assume that certain cities have a relevant proportions of people with other ethnic groups. If you make this hypothesis, then you can it is acceptable. Of course, the more you use a car, the higher is the probability to make an accident and to have higher cost. But this is not related to ethnic group, so it's not an explanation of the discrimination. Same for age. Usually, the younger you are, the higher is the probability to have an accident. That's why you pay more with your insurance. Well, unless you inherit the risk, the level of your parents. There is a special law in Italy that allows that. So far, so good, because it doesn't change nothing. There is no correlation in this context, in this specific context, with ethnic group. So certainly we have a correlation with the target variable, age, and then claim history. The older you are also, and the longer, most probably, is the claim history. But you could not explain the discrimination with such variables. Please notice that this was not invented. This was a real audit made, and you find the link. Then I turned it into an exam, but I think I put the link, right? Yes, you have the link of the scientific paper, and then the paper had also media coverage. La Repubblica and other national newspapers covered this scientific study. Actually made from colleagues of University of Padua, so some Italians. This is a possible explanation. This is the starting point of an audit. This is what you are expected to achieve at the end of this course. Then, of course, you need the statistical data to check that all these hypotheses are correct. In real life, you would need to check all of these links. But this is the starting point. When you do an audit, this is the model, the causal correlational model from which you start to identify the risk of discriminations. And you have to take action against this to mitigate the possible risk. Okay, nothing to remark on the most common errors in this exam. Example of measurement issues. You will find that my reasoning is about the feature space that is very limited in terms of the actual factors of accidents. So my reasoning is that the information that is collected is in any way poor because we have other risk factors that are more important, like the age of the car, the status of maintenance of the car, the weather conditions, the status of the roads, and so on. So this is a possible issue that you could remark in this specific exam. The model is that is built, the features that are selected are not the best. Then you have here the fact that the luxury cars are a very, very special segment that could provide some outliers, and that should be devoted a specific model. Number of claims should be normalized by age or by number of years driving to avoid this link. And finally, the ethnic groups was collected without considering other attributes. And why I mention it here? Because in the ethnic group, we had only levels, where it is, Caucasian, Black, Asiatic. They might not be representative for the Italian population. They are taken from the common US attributes. And some other ethnic groups are missing. So a category order should be placed. So these are examples of measurement issues that were acceptable. Others were also acceptable, depending on how you present them and the reasoning that you explain. Most common errors that I found in that exams that you repeat the discrimination analysis also. So you present some discrimination issues as measurement issues. No, that was part one of the question. Or very poor explanation. So you indicate a measurement issue without explaining it. So remember to explain everything. Otherwise, I cannot really accept it. Now, third questions. And here was really a bad surprise, because I asked which changes in the experimentation data collection process would you introduce to check fairness in terms of separation? And most people, really more than 50%, did not read this last part of the question and automatically thought that this was the common question of improvement. No, actually asked a very specific thing. What do we need for computing separation? We need error rates. So we need to collect the actual data after doing the quote. So this data that is collected and is treated in the exam is only the data entered when you get a quote. You want to make insurance for your car, you connect to the website and you get a quote. But then if you want to get the error rates, you need to continue the experimentation and collect data after the quote to check whether the quote was the risk level that was determined and that was proportional to the quote was adequate or not. So this was the improvement. It was just one line and was enough to answering this question. Unfortunately, many of your colleagues, not you, lost this 1.5 point. These questions of theory is mostly related to the part that was covered by the Martin. So don't take it as an example for theory questions from my side. Take the exams from last year as examples of theory questions that I could make. Do you have questions? Otherwise, I will close with the solutions of the last time. Okay. I hope that this was useful for you and I recorded it. Now, let me introduce the first exercise, because this is a new type of exercise. It is fairness computations. And the first exercise for today, we will solve the first one partially together, and then you will be left with the other two. Predicting severe flu symptoms for elderly patients. This was the special session of the 2nd November of a few months ago. Take care that I used this first exercise to make for you a simulation of exam. So it's already active. You should find already on the portal through the platform exercise. You should find already a hypothetical exam with this exercise plus a theory questions. It is important that you try it in order to check how exam platform work in case you didn't have the opportunity to check earlier, whether your laptop works good with lockdown browser, because we will use the lockdown browser, and I cannot accept that you come at the exam and you say, I don't know how to use the exam platform. So you have already well in advance a simulation exam that you should try to check that that your laptop, your browser, compatibility, your hardware, that everything is fine. So please use it just to be sure that you won't have bad surprises at the exam. Now let's go to the exercise, predicting severe flu symptoms for elderly patients. Data-driven algorithms can be employed to screen and predict the risk of various forms of diseases, including common flu. They can find patterns and links in medical records that previously required visiting a human doctor. Algorithm predictions can be used by patients to decide whether to see a doctor for their flu. Suppose we have two different algorithms predicting the severity of flu symptoms in patients and would like to decide which one should be deployed in the real world. So you have two algorithms, read two models, is the same. We don't have the features here, they're useless. We have the results of an audit, an experimentation. Each algorithm was tested on 400 elderly persons. So 400 for algorithm 1 and 400 for algorithm 2. And results are shown in table 1 and table 2, divided by gender, female and male, with a binary classification, male, female. prediction to develop severe flu symptoms is marked with R equal to 1 in the tables, otherwise R equal to 0, and Y equal to 1 is the target variable. So the actual development of severe flu symptoms is marked with Y equal to 1 and Y equal to 0. So this is the common format. This is the format that in the slides you find for computing a separation. Question 1 is which of the two algorithms is preferable in terms of lower systematic discrimination by gender and why? Support your reasoning by showing computation of unfairness criteria. One, only one. This is important because sometimes I write one, I underline only one, and I still find more than one computation. And if you make errors in one of the computations, I cannot take only the right one. So stick to the question. Only if I write only one, and especially here I wrote and repeated, only one computation. And if I ask only one computation, it's because the answer is the same, regardless of the fairness criteria that you choose. I design tables in such a way that doesn't matter which fairness computation you choose. This was 4 points. And then the second part is consider the possible errors of the predictions and their social implications in the context of application. So which common limitation of the two algorithms do you observe? So even if algorithm 1 or 2, you will see in a while, is preferable, which limitation is still in common in the two algorithms? And considering, I think that I help here, the possible errors of the predictions. If we want to compute independence, you might have had, if you studied mechanically the computation of independence, you might have made the errors of taking only 20 here and dividing it by 100. Because in the slide you have one table in which you take this cell and you divide by this one. But the table of independence is slightly different from the table that is built to compute separation. So I call it difficulty because I saw this error many times. The difficulty was, and so I think that was because of the pressure of being in an exam, the difficulty was to, let me take the pen here, to compute independence. Okay. Wait a second. You should take 20. Independence is the probability of predicting positive for a given gender. So who are the positive ones? For my female, 20 and 10. And you should divide them by 150. The probability that R is equal to 1, given that the attribute is a female, 20 plus 10, the sum of the ones that are predicted 1 divided by all females, divided by 150. That is 30 divided by 150 and was 0.20. The same for, so this is for algorithm 1. The same for males. It is 60 plus 50 divided by 250. This was 0.32. The delta is 0.12. You should compute the gap between female and males. Do you have questions or is clear? Yes, please. We are not delving into explanation of discriminations. We have to make, in this type of exam, we just have to say which of the two algorithms is preferable from the point of view of gender discrimination. So the one, we should identify the algorithm that discriminate less between genders. You don't have, it's another type of case. It's not a case where you should reconstruct and explain the cause of discrimination. So I cannot even answer to your question because it's totally a black box here. And the goal is not to explain discrimination, is to check in terms of fairness criteria. Yes, please.
We should do 60 plus 50, not 60 plus 20.
50, yes. Sorry, I said 50 and wrote 20. This is sorry, wait, one per. Yes, yes, this is how I underlined, and this is how I messed up everything here. Thanks a lot. Sorry. Yes. 0 dots. Yes. So I took algorithm 2 and I put the results of algorithm 1. I made I didn't realize that I was already in algorithm 2. Sorry. And this is algorithm 2. The steps are correct. So I just messed up with. Sorry. 60 plus, so algorithm 2 is 20 plus 10, 20 plus 10 divided by 150. Male 60 plus 50 divided by 250. I apologize for having made this confusion. Algorithm 1 is 20 plus 10 divided by 150. So algorithm 1 is for female, is is 30 divided by, well, it's the same, is 0.2. Then I will, for male is 60 plus 20 divided by 250. Okay. Wait, I'm making again confusion. So this was 0.44 and delta 2 is here, delta 1 is so the delta is less for in absolute value for algorithm 1. So we prefer, from the point of view independence, if you selected independence, algorithm 1. Yes, please? No. If you put only the results, I cannot accept it. But if you make a computation, if you want to be sure, you show also the steps, at least for one, so that I can differentiate if you made just a computation error, that is a really minor error, and or if you made a conceptual error in the computation that made a difference. I wanted to make this computation because I found many errors because of the shape of the table. Many in this exam when computing independence. Can I go on with separation and sufficiency? Sorry. Okay, separation will be in blue. Okay. Separation concerns the error rates, true positives, false positives. So there are more computation. However, because the shape of the table is exactly the shape for separation, was easier because for algorithm 1, the number of true positive is given by this 20 because they are the female that are predicted 1 in the right way divided by 100. And so this is 20% or 0.20. And for male is the same, 60 divided by 150, that is 0.4. And the delta here is 0.24 to positive. The same is for algorithm 2, is 20 divided by 100, and then is 60 divided by 180. And if my notes are not wrong, but it should be 0.33. The delta here in terms of true positive is 0.13. Sorry?
The other one is 32.
Here?
The division of 80 to 200.
Say again, please.
80 to 250.
No, we are taking, so this is separation, 60 divided 180.
Algorithm 1.
60 divided,
80 divided by 250.
so algorithm 1, which cell, here or here? Here, right? I don't understand.
I think I get it.
Huh?
I think I made a mistake.
Okay, yes, okay. Maybe I was, so this is the delta of this and this, it's not the delta of this line. This is the total, okay? The total, we don't take care of this because you have mixed information, female and male. Okay. Can I go on? False positive. What is false is what is predicted positively, but was not positive, was y equal to 0. So is 10 divided by 50. It is 0.2 again. And 20 divided by 100 is 0.2. So here the delta is exactly 0. And obviously is the table below, since it is, I presented it in the same way, is 10 divided by 50, that is 0.2. And then is 50 divided by 70, which is 0.71. The delta is much higher. So here you have a particular situation because you have that the delta is slightly better for the true positives for algorithm 2. You see here the delta is 0.2, here is 0.13. However, the delta for the false positive, this is the second condition for separation, is so high here that algorithm 1 is preferable also in terms of separation. Did you understand? So here they're very close. But here this difference is huge. So outperforms this difference. Just waiting a few seconds if there are questions. I didn't do an average because it was so clear that an average could. You could say they are equivalent. Or if you choose the average, you can use the average and say, making the average of the two differences. You could also reason it's more important in this specific case to have a wider delta of true positives or false positives. You explain why, and that's fair enough. But if the explanation is fine, okay? Okay, last separation, and then we will start with the, you will do the exercise. Well, then we will answer to question 2, and then you will start the exercise. Okay. Let me check. This table was the table that is mostly prone for separation computation. It should be reversed to make computation of sufficiency if you want to stick with the slides. Otherwise, you could reason in these terms. Separation, the condition in insufficiency, sorry, is that is on the classification probability that y is equal to 1 given that r is equal to 1. You can check quickly in the slides, but the calibration is that given the positive class, given the condition is on the classification. Then for a given attribute, this is the short form, whatever a. Okay. For the bias probability, this is equal to the joint probability y equal to 1 and r equal to 1 divided by the probability of r equal to 1. Do you agree? So if you remember, even if you get a table that is not the right one, if you remember the formula, you take what you take 20. So let's make the first this first part of sufficiency. For algorithm 1, the joint probability that y is equal to 1, r is equal to 1 is always 20. But the probability that r is equal to 1 is the sum of the cells where r is equal to 1. So it's 20 plus 10. And so let me check a way to make it clear. Positive predictive value, this is the first term of sufficiency for female. And so for algorithm 1 is 20 because it's the joint probability of y equal to 1 and r equal to 1 divided by 20 plus 10. It are all females that were predicted 1, sorry. And this is 0.67. Clear? The positive predictive value for males is 60. Divided by 60 plus 20 for the same reasoning. You follow me? This computation? Yes, please. Can you raise your voice because I cannot hear you?
You just say that it was regardless of the gender.
Why?
Just earlier you said that you also wrote it for each day. So I thought it was going to be regardless of the gender. So
No, I meant to be short, I wrote regardless of the gender, it means for each gender. Yes, for each gender. See, sorry. Take as a reference the slides and the formula. Here I wanted to make it short and fast, okay? Then for algorithm 2 is symmetric, that is 20 is the same for female, while for male is 60 divided 60 plus 50. And is equal to 0.45. You have here a delta of 0.08 and here a delta of 0.12. So they are mostly equivalent, but algorithm 1 is better. Now let's compute the pulse of omission rate that is similar because pulse omission rate for females is, we have two reasons in terms of r equal to 0. So that formula probability that y is equal to 1 given that r is equal to 0, that is, for bias, the joint probability divided by the probability that r is equal to 0. And so this is epsilon equal to 1, r equal to 0 is 80, divided by all the labeled 0. So is 80 plus 40. So this is 80 divided 80 plus 40, and should be let me check. Yes, 0.67. Or for males is 90 divided 90 plus 80. This is 0.53. The delta is 0.14. And for algorithm 2, is symmetric because it's 80 divided 80 plus 40. So 0.67 is the same for female, while for male is 120 divided by 120 plus 20 is 0.86. Delta is 0.19, right? Yes. So false omission rate is less for algorithm 1. Positive predictive value is less for algorithm 1. So again, the answer is algorithm 1 is preferable. Now quickly, because otherwise you won't have time to make the exercise by yourself. About the second part of the question, this limitation that is in common of the two algorithms regarding the errors. Errors can be either false positive or false negative. So if you look at the number of false negative in this example, they are very high. They are sorry, is 80% for female, 80 divided by 10, 100. 80% also in algorithm 2, 80 divided by 100. You see, they are false negative. They are predicted negative, but they were positive. And is 0.60 for male, 90 divided by 150, and 0.67 for algorithm 2, 120 divided 180. This means that with 80% of false negative and almost 70% of false female, this is in both algorithms. this is a huge limitation because you cannot trust the negative predictions. So it's like you don't predict a flu as a severe when it is severe. And this is a big social implication because you are missing people that should be treated carefully with higher medicaments. Okay? Did you understand this point? So the false negative are still very high. You could even not compute a false negative that pointed to the number of errors, even without computing the exact percentages, but showing that's 90 over 150, showing computing all the errors. Okay, let's wait a few seconds if you have questions. You can now read by yourself exercise 2 because it is very, very close to this one. So it's a very good exercise because it's very similar. And then you go on with exercise 3. So you do 2 and 3 in a row. Christian is here, that helps you. You manage yourself with a break. And in about roughly an hour and something, I can check with you the solutions without redoing all the computations because they're the same. But I will upload the solutions. You can check. You can ask me questions. Christian will stay like me until the very end. And that's all. So you can start with exercise 2 and exercise 3. Make them in a row. As I was saying, the first question was identical, while the second one was slightly different because I asked you to focus only on the second, on the algorithm that you indicated as the most preferable, and to identify only one limitation that you still observe on that algorithm that was identified. I was saying that I remember that many people left indications for both algorithms. And again, it's a problem of reading carefully the question. I'm just telling you the frequent errors that I saw. You will see the results of the computations. I'm not doing them step by step. I uploaded the file that we did earlier, and I think that you can check whether your computations are correct, and if you don't understand why, you can we can check it together. You ask me or Christian, and I will come. And regarding question 2, again, was you could reason in terms of error rates, both in terms of false positive rate and in terms of false negative rate. Algorithm 2 was the most preferable, but even if it was the most preferable, the error rates are so high that should be not deployed. The limitation is on the error rate because we had approximately, on average, 6 out of 10 patients, regardless of the ethnic group, or 50% for white and 75% for black, if you made the analysis separately, that are false positive, means that they go unnecessarily through the high risk and medical possible interventions or through further treatments, and this is an unnecessary cost. Or you might also provoke or damage the person if you make some how they're called, some analyses that are very invasive, for instance. So this is the cost, also not in economical terms, of a false positive. False negatives are also very high, is 50% for both subgroups, and so you are losing half of the negative predictions. And given the context at hand, that is cancer prediction, this is not good. So this is a limitation of algorithm 2. The errors are, even if separation was better, and in terms of true positive was even at 0 as a delta, and if false positive was not okay, but was not horrible, was 25%. The error rate is unacceptable, given the context at hand. So this is all regarding exercise 2. Exercise 1, as I said, you had 4 tables because there were 4 versions of the exam. He was asked to comment the results and to list any other ethical issues, including measurement issues. So both questions were on purpose very broad. In the guide to the solution, you will find computations for independence and separation, and examples of comments for independence and separations. For example, you have that independence is respected in almost all cases. You have a delta of 6-7%. You have a case, table 3. So if you had table 3, and if you computed independence, you have that the probability of positive classification is skewed towards foreigners. In fact, table 3 is 0.31 against 0.76, with a delta that is considerable. So here you have a problem. As far as separation is concerned, we have, in all cases, the true positive rate, as it was observed by some of you, is much higher for French people rather than non-French people. And I reasoned in terms of data quality. Given the type of data that is collected, we could assume that quality of data is higher for French people and less for instead for non-French people. For example, I made consider that you use if you are a German and you use Amazon.de, and this data is not tracked in Amazon.fr. You use a different domain. You use different commercial websites. It's just an hypothesis, but it's a plausible hypothesis that could be the reason for this relevant difference in true positives. Then in false positives, there was very similar in cases 1 to 4, not for case 3, was a considerable difference, 49% more for foreigners. So you could not trust that predictions. So that here was made on purpose. The possible answers were really a lot, depending on the table that you received. I think it could be meaningful to check the type of measurement issues and generally speaking ethical issues. So the first one, that is only high volume e-commerce sites are analyzed and not other type of purchases that could be more relevant to understand the level of wealth of a person, that could not correspond to the tax that are paid. Then social network access is not uniform across the population, but also the patterns of usage of social networks are very different. Old people, younger people, etc. We already discussed this in theory. And since the social network is a source of data used here, this should be taken into account when relying on these measurements. Here, the wealth indicator is compared with the average of the last 3 tax returns. This is written in the text. However, for foreigners who moved very recently to France, you might have no data that represented that kind of population. This is also a possible measurement issue. And then this was very broad, and I could accept it only if it was not the only issue that was identified, that the purpose of data collection is different here from the usage made by the authorities. So you are using data that was collected for totally other purposes. However, this could be legal because when you use Facebook and any other website, you agree that your data is used in any case. If you think that I invented everything, this is wrong, because again, I took inspiration from reality, and you can find some links here. So this closes today's exercise. I will stay here until the end if you have a specific question. The next week, I remind you that we will go ahead with a theory on Monday, and probably I might present you some thesis topics. And on Tuesday, we will make another session of exercise. The category of exams will be on discrimination risk. That is similar to explanation of discriminations, but you don't know whether there is a discrimination or not, and you should identify the risks of discrimination. And I will not solve next time, since the typology is very similar to explanation of discriminations. I will not solve together the first exercise, as I did in these first 2 slots. So since the beginning, you will be given the text, you will start doing the exercise. I and Christian will be here to answering. And this is how next week is organized. Okay, thanks a lot. And if you have any questions, I will take. Otherwise, have a nice evening.